Sorry. Okay, let's start from the beginning. The earth cooled, then dinosaurs came. That's mine. Start from the beginning joke. I keep recycling. So the question we had on Monday was the machine who fixed your upper extremity. Is that correct? And it allowed your pelvis to rotate. Is that true? Okay. So let's make sure we're all looking at the same machine. The reason I like that machine is because we actually have one of those in the weight room. Does anybody ever use that machine in the weight room? The little trunk twisty thing? Now last semester, I had, and look, it was a great question, and I just spent about 15 minutes, bless you, trying to explain why that wasn't happening because of hip muscles. I'm going to try some keywords and see what happens. There we go. I think it was maybe this one. Is that correct? Is that the specific question? You can't just see through it, man?
Not bad. I'm having one of those days, guys.
Is that the one? Okay. So, in 310, one of the things I taught you guys is we have to look at our jobs, and that's across all fields: athletic training, physical therapy, occupational therapy, physician assistant, coaching, strength and conditioning coaching, CrossFit coaching, whatever you do, man, you got to be a detective, because sometimes you got to figure stuff out. You have to look for clues in order to figure things out. So one of the things we look at is, on this picture, in terms of muscles and work, and that I know that this person hasn't yet started the action phase of that motion. This is the start position. How do I know? Because the plates aren't separated, okay? So the person's going to be starting here. In addition, I know that the upper extremity is going to be fixed, and she's going to be making her pelvis rotate all the way to the right. By making her pelvis rotate all the way to the right, that's making her trunk twist to the left. And again, it's a similar illusion as this is just as much right transverse cervical rotation as this. Okay? When she first starts in this position, she's going to have some all-the-time trunk rotators, and then that pes rectus abdominis, candid or candid. Okay? So if she's here and she's going to make left transverse trunk rotation happen, she's going to need to use her left transverse trunk rotators. Who are those muscles? Right external, left internal, left rectus spinae. Those are the all-the-time muscles. Those are the muscles that are going to work the entire range of motion, trying to bring her right shoulder closer to her left pelvis. Does that make sense? Now the rectus can offer some assistance, but not the entire range of motion. In fact, the rectus is going to help her when she needs it the most. The hardest thing to do is get it going. Like when, again, I use the moving furniture analogy. Pushing a car that's out of gas, the hardest thing is getting it going. Once you get it going, it's not as tough to keep it going because it has momentum, right? So it's actually brilliant that rectus could say, hey guys, I can give you a little extra help here to get it going. And then once you have it going, the rectus is like, you're good, keep it going with the momentum you built up to it, okay? Now, as future therapists, fitness professionals, knowing this extra help you get sometimes, that may determine where you start certain trunk exercises. In other words, if you reposition it to start it at midway and say, I want you to start here and do this, guess what? Your rectus wouldn't help. Then that would be just right external, left internal, left rectus spinae with no rectus. Sometimes you may want to just isolate those muscles to get the momentum going. But I think it's important to at least be able to observe when you do have extra help and when you don't have extra help. Okay. Would there be any change to the muscles in terms of quadrants? Let's look at it as a quadrant. Let's say she starts here, and quadrant 1 is going to be like the first 90, and quadrant 2 is going to be the second 90. Okay, so anatomical position of her trunk would be the transition between quadrant 1, where she starts, quadrant 2 on the other side. There would be no change in muscle health, regardless of concentric or eccentric. The only thing that changes is the type of work. So in other words, if my rectus can help me in quadrant 1, and it can't help me in quadrant 2, guess what? It's going to continue to not help in quadrant 2, and then start to help me back in quadrant 1. Because if it can shorten while trying to shorten, it can be lengthened while trying to shorten. Does that make sense? Okay. Let's ask a different kind of question that might be on your test. What if I, for the lack of trying to find a picture, I'll just do it. Okay. Identify which group of muscles would be stretched or lengthened from anatomical position if I did the following. For visual, if I started here and I did this, what are a few of the main muscles? Don't answer right away. I want you to be able to think about it. Position, what's being lengthened, and sometimes what's being lengthened could be seen easier if you see what's being shortened. Does that make sense? So maybe you're the kind of person, it's like planes and axes. Some people see it better by the axis and then say, well, if it's this axis, it has to be this plane. Some people see it by the plane and say, well, if it's this plane, it has to be that axis. So when we're doing these stretching examples, maybe one way to show what is being lengthened is to show what's being shortened. And if you know what's being shortened, then by default, you know what's being lengthened. Just a couple of techniques. Okay? On the test, I'm probably not going to name all of the major players. I'll probably just identify like a left external with a left internal, or a left external with a right internal, or a left external with a right external. Right? I'm going to mix and match so that way I could have two different options, just like I did in 310. Okay? So, what's the position of my trunk, regardless of if I move my trunk or not? Aren't I looking at my left hip? That means my trunk is twisted to its left. How do I know that? If I came up and I say, go back home, wouldn't I have to twist to the right to go back home? It means I'm twisted to the left. So if I'm twisted to the left, my right shoulder is closer to my left hip. That means the muscles that pull this way are at their shortest, and the muscles that pull the other way are at their longest. So who am I stretching here? I'm stretching my right transverse trunk rotators, and those are the left external, right internal. Any questions or clarifications about a question such as that? The reason I don't give you a lot of sagittal or frontal, that's pretty darn easy. If I'm doing a back extension stretch, I'm stretching all my flexors. And if I'm bending to the right side, I'm stretching the ones on the left. I'm really emphasizing the twisty ones because that seems to be the ones that are kind of not as easy to see. Okay? All right, let's try this one. If I can find a good picture. Sometimes these keywords, man, you never know what you're going to get. I want to find one. Oh, this isn't that bad. Oh no, he repositions his whole trunk. That's bad. And again, guys, don't misunderstand. Like, I'm not saying that exercise is bad. I'm saying the picture that I want to use so that there's no ambiguity. That's what I'm looking for. Maybe if I look at oh, here's a good one. Bless you. So The reason I like these kind of questions is because if you think about the trunk as like a teeter-totter, right? You know, like a seesaw, right? You got one side, other side, seesaws. It's kind of how the trunk is. You got one side of the teeter-totter, other side of the teeter-totter. Well, when you have two dumbbells that are the same mass, they kind of cancel each other out. Does that make sense? In other words, the weight on the right side is trying to, the one on the left side is trying to do that, so they kind of balance themselves. So that's why you kind of need to have just one teeter-totter, one weight. So that way the weight's trying to do this, so you got to use muscles on the other side. So, okay. So which group of muscles, and notice how I'm going to communicate it, in the trunk's frontal plane, that immediately eliminates, well, I thought you were going here, or I thought you were going here. I'm being very specific to the plane of pull of the muscles that I want you to identify, okay? So frontal plane, the process doesn't change. External force, where you got more stuff on the right side trying to bend you to the right. So guess what? You need muscles that pull you to the left to either keep you here, let you go down, or make you come back up. So your circles are a technique that you can use to identify the major muscles that are pulling your trunk to the left. It's the stuff on the left side of the belly button, the stuff on the left side of class. Left rectus, left external, left internal, left erector spinal. And again, I'm not saying there's not other ones, quadratus lumborum. You can learn that in grad school. I'm just trying to get you to see how this game is played, the major players. And it's about how they pull, how they cross. Not necessarily exactly what they're pulling on, but how they cross that joint in order to pull in the direction that you need to do the job. Okay? So in other words, on the test, I might say, which oblique, right or left, brings you up, and then which oblique lowers you down. And on the test, man, I'm fishing. I'm going to be like, left external brings you up, right external lowers you down. Does that make sense? No. It's the left external for both. The left external is going to bring you up, keep you up, and lower you down, because the external force is already trying to do that. So that's why I want you to re-practice that 310 stuff so that I can make the new stuff a lot more practical and understandable. Okay? Does anybody have a question or clarification of why he would be working the left lateral trunk benders for the entire exercise? Lowering himself down, bring himself down. Now, could he work the right? Yeah, if you want to like throw the weight down. In other words, you already have some that's trying to tip you over to the right. If you actually use muscles that pull that way, you'd be going faster than gravity. Thank you, Veronica. I'm joking, I don't think that's wrong. Can't be ready to know who wrong is. All right, trunk flexors or trunk extensors? Now, you could say neither, hip flexors, that's cool, but you still need some trunk muscles to create the rigidity and come up. So I could word it as, which group of muscles in the trunk would you need to maintain a rigid length? In other words, to do a job to create a rigid length as you come up. So I'm not disrespecting what's happening in the hips. It's just, guess what? Your test is on trunk stuff. I'm going to give you trunk questions. Okay? So which group of muscles? Now this is what's really cool. Some of you have been introduced to the concepts of co-contractions. And co-contractions, that's basically you have some in the front, some in the back working, even though you need muscles to in motion. A lot of that has to do with stability, guys. You never want to turn off all your erector spinae, because one of the roles they have is to make sure things don't go out of place. So a lot of co-contraction stuff is the antagonistic muscles still being active to an extent to maintain the articulations of those joints themselves. However, when we're looking at motion stuff, causing motion, allowing motion, slowing down motion, preventing motion, I'm asking you who's doing a specific job to not allow his trunk to drop back. Does that make sense? That's above and beyond the other part doing a stability component. All of my questions are rotary components, motion-based. Okay? So who does he need to recruit to do a job here? You need the front muscles, right? Trunk flexors, rectus abdominis, right and left, externals, internals. I think a tricky one that I've seen used is a tricky one. It's not tricky. You guys can figure this out. Watch where it's all about external forces. Good Lord. Okay. So in that exercise, you use the trunk flexors, and they were on the top, like globally referenced, right there on the top. So you spin it around, and someone who might shoot the gun may not look for the clues, may not ask themselves, what's the external force trying to do? They may say, well, if you needed the top muscles when you were doing this, then maybe you need the top muscles when you're doing that. Just the assumptions, right? You don't assume. So what I want you to see here is that not only do you have gravity here, but you have the ground pushing at 2 points. You have what we call a 3-point bend. If I took some silly putty and I did this, would it sag on the bottom, right? Because my two hands are keeping this part up and it's just sagging in the middle. If he relaxes all of his trunk muscles, he's going to sag down, and that's going to cause trunk extension, right? In other words, the ground pushing up at his feet and his elbows, and the center of the planet pulling down is trying to extend his trunk. Can you see that? You don't need your trunk extensor. You need your trunk flexors to create a rigid link to prevent that extension. Does that make sense? So here you would need your trunk flexors. What about the cervical vertebra? If you use your trunk flexors, if you need your cervical flexors. You see how it'd be sent? But no, there you actually need your cervical extensor because you don't have anything pushing you on this end. If you relax all your neck muscle, you have to flex. So you need your extensors to maintain this position. Does that make sense? So again, you don't assume. It could be an exercise where you need the flexors at the trunk, but the extensors at the neck. Let's do the side plank. Let's do this one. Can everybody see that? Oh, Brian. Okay. Trunk and neck. Identify the group of muscles. Once you identify the group, because you understand why it has to work, then you can get into your circles and once you identify the group, then you can say who's in the group. What are those muscles? The circles don't tell you if anything's working. The circles just help you to identify who is in that group that you need to do a job. Okay? So try to work through that either on your own or in your small groups. Identify the agonist at the trunk and the cervical vertebra, and then we'll get some motion to it, which doesn't change the muscles, but it changes the verbiage about the concentric units. Okay? Go. Let's see. Okay, guys? And listen, I want to make sure everybody understands that you are more than welcome to to do an experiment where you get on your left elbow and maybe you feel what kicks on in terms of what side. So you're always welcome to test drive. Okay? All right, guys, so let me try to word it in a way that you're going to be tested on it, okay? So if I asked you to identify one muscle, now again, I'm not disrespecting the other muscles, I'm just asking you to identify one muscle that would be helping in that job at the trunk and the cervical vertebra respectively. That means first answer is the trunk answer and the second answer is the cervical answer. And then I said left external, left sternocleidomastoid. Left external, right sternocleidomastoid. Right external, left sternocleidomastoid. Right external. Now, obviously on the test, I'm not going to abbreviate. I'm dyslexic. I don't like writing things. So if I asked you to identify trunk and cervical, trunk first, cervical, this is what I would do. I wouldn't look at the answers at first. I would say I need left lateral trunk benders, and I need right lateral cervical benders. I need them to do a job. The left is going to prevent me from bending to the right, and the right is going to prevent me from bending to the left. Then once I've identified I need a left lateral trunk, I say, well, which one of these obliques is a left lateral trunk? Okay, these are still in the game. I can eliminate these. I need right lateral cervical. That's not a right lateral cervical. That's a right lateral cervical. Doable? Now again, none of the answers change if I say this happy guy lowers his body down, because it'd be the same muscles, just to be introverted. He raises himself up, same muscles, just a constant version. Why do the muscles stay the same? Because gravity and the 3 points is still trying to bend him down. Are these helpful? Okay, I'm going to give you, Brian, I haven't been able to find this, so I might have to just demonstrate it for you guys. Wait. I'm just going to throw up a Hail Mary and see if I can find something. And the answer is... Okay, so what I was trying to find is, let's pretend somebody was laying on, their feet was on a chair and their back was on a table. So like they're basically like a board, right? I know this may seem like it would be at a circus, but just let's pretend. So someone is stiff as a board, they are supine, feet, table, and it could be their upper extremity. And then someone puts a 45-pound plate on their lap. The illusion is that the plate is here and it makes you want to think here. But the reality is that if you're like this, you want to bend this way, and that's trunk flexion. You actually need your erectors. You know what it is? It's the exact opposite of if you're here, you need your flexors. Well, guess what? If you're here, you need your extensor. but the illusion of putting the plate in the front makes you think that you need the front muscles to prevent the bend, and the reality you need these guys to prevent. That was the picture I was trying to find. I can never find it. All right, how about this? Okay, too much stretching. Who's being lengthened? The group would be the right or left lateral. Remember, it's from the person you're observing, not from the observer. You could always put yourself in the position of the observer, but you can't say that's right because it's your right. That's her left. Okay? So she's bending her neck to her left. What is she stretching? The stuff that pulls back to the right. The right lateral cervical benders, the two main ones that I'm only holding you accountable for, sternocleidomastoid erector spinae on the right side. All right, let's try a, if I can find one. Let's try to twist it. Oh, wait, let me use this term. Okay. What if I asked you to identify which specific sternocleidomastoid, just the right or the left? The picture on the left. So if I say the picture on the left or the picture on the right, obviously that's from the observer's perspective. But if we're talking about their muscles, their motion, it's from the observee's perspective. So picture on the left, which sternocleidomastoid am I stretching? You know, it's crazy. This picture, like, gives a big hint on what's not being stretched. Okay. So, right or left sternocleidomastoid? The left. Now, again, your instinct is to be, well, how can I be stretching something when I'm actually moving to the left? And it all is based off of its angle of pull. I used a little string to give that example of how, if I have a string here, this is the line of the sternocleidomastoid. If I actually look to the right, it gets shorter. By looking to the left, it gets longer and actually wants to pull me back. Her right one actually lost its obliquity. Her right one is now what a rectus abdominis would be in that position. In other words, it's just pulling straight down. Okay, which erector spinae would she be stretching on that same position? Right erector spine, yeah. That one you'd be lengthening because it wants to pull your back. Okay, how about something like this? First of all, guys, is this helping? All right, what if I asked something like this, and I said, oh dear. Okay, what if I asked something like this, and I basically just asked you to identify which external oblique would be working more, or which external oblique would be the agonist that's agonist. In other words, between the left and the right, who would be getting more of a phone call to do a job? Yeah, her right. If she relaxes herself, she's going to twist back to the right. That means she had to make herself have a twist to the left. Left transverse trunk rotators, which external oblique is the left transverse trunk, the right external. This is where it gets confusing, guys, and understand you have rights that pull left, and you have lefts that pull right. We just have to remember to separate those things. I can have a muscle on my right side that's trying to spin me to the left. Okay? I can have a muscle on the left side that's trying to spin me to the right. So the right and the left muscle just literally mean one on the right side and one on the left side. Its motion is separate than its location. Okay. Now, for this one, obviously there's going to be a component of trunk flexion, right? So, but it's only that one half of it, so like that external oblique would be working transversely and be working sagittally. But on the test, I would just give you one component. I wouldn't make it matrixy. I wouldn't make it matrixy. I would just basically say right or left external. Who's doing more work? Okay, how about something? Well, I'll tell you what I think I'd like to do. Let's go back to an original question and see if this is a lot easier to answer now that we've been kind of practicing, okay? Let me find a different picture though, okay? All right. Okay guys, this time we're going to start on the bottom. Similar question, but a different way of asking it. We're going to start on the bottom, and he's going to bring his feet up. He's going to continue his motion and lower them back down. Specifically, the kind of things I would like you to tell me is, which muscles, let's break it into quadrants. Let's say quadrant 1 is where he starts. And then right past you get anatomical position midline, and then you kick over as quadrant 2. So in other words, you're pouring water out the right side, that's quadrant 1, pouring water out the left side, quadrant 2. So I'd like for you to identify specific muscles that will be working in quadrant 1, and then specific muscles in quadrant 2. Maybe they're the same, maybe they're not. And then the secondary question is, can the rectus help any of those groups with their task, with their job? Okay? Ready? Go. Obviously, coaches a team, so the photos we can use as a team kind of photos, but I want to kind of isolate individually. Well, no, the one we posted, the one where we celebrate, those are approaches. Yeah, and then borrow is just a field one, two, Heisman, or any other isolation, just Joe. Okay, guys. So, and different techniques, man. And remember, man, you don't have to use the same technique. You just want right answers. The way I look at it is, if I was going to attach a rope and pull, that rope would line up with the obliques that I need. It would. If you attach ropes to the end of his feet to pull in this direction, that would actually line up with his left external and right internal obliques, because that's who's working right there. Literally working to pull the pelvis back this way. So what is the left external and right internal? Right transverse trunk rotators. If you look at it another way and say, well, no, Campbell, that's I just want to do what's the external force trying to cause. No problem. In quadrant one, the external force is trying to spin his pelvis to the right, meaning that it's trying to make his trunk spin to the left. If it's trying to spin the trunk to your left, you don't need left transverse trunk rotators, right? You need right transverse trunk rotators. So either way, it gets you to the same thing. I need right transverse trunk rotators, not to literally spin my trunk, but to spin the pelvis. Same muscles. We did it in the first example. Okay? However, those right transverse trunk rotators aren't going to be working the entire range of motion. Once you tip it over to quadrant 2, well, now gravity is trying to do the exact opposite to your trunk. Now it's trying to spin your trunk to the right. So you're going to need the other muscles. You need the left transverse trunk rotator. Now, that's the all the time trunk rotators. In other words, quadrant 1, external, internal, erector, quadrant 2, then you say, well, what about the rectus? The rectus can help both. I think that's what's great about this exercise. That although the obliques change as you go from quadrant 1 to quadrant 2, the rectus can help both of them. Not at the same time, But the rectus can go from making you go back to letting you go away, and then making you come back, and then letting you go away, and making you come back and letting you go away. Any questions? Yes, sir.
Is it both sides of the rectus or just one side?
Both sides. Because the way it works is, let's just pretend that we're in an anatomical position. When you twist, both of them get angulated. When you twist, both of them become obliquulated. Both sides.
So the muscles working in the bottom, since the left external is getting stretched and the right internal is getting shortened. Are there
That's not verbiage, right? And first of all, you're fine. I'm not fussing, I just want to clarify. If we just stay in this picture, right, neither of them are getting stretched or lengthened. Isometrically, right? So my point is that if you start to go up, both of them are shortening. And if you lower yourself down, both of them are lengthening. The only way you can have one shorten while the other lengthens is if we go frontal planes. Does that make sense?
Okay. So what are the muscles working in the bottom picture? What would you say the muscles are?
Your left transverse trunk rotators, that would be your left external, right internal, right erector spine. With your rectus abdominis, because your rectus abdominis can be engaged because your rectus wants to pull you back anatomically. So the external force is trying to lengthen the rectus in the transverse plane, so therefore it can be activated to either let it lengthen, make it shorten. And then when you flip the other way, it's the same thing. It's trying to do this so the rectus can be lengthened while you go out, and it can shorten and bring it back. Good question. I hope you didn't, like, whoa, let's make sure we're talking about the same thing. Okay? This is the toughest question you're going to have in biomechanics. This is not easy. When I get asked about this, I have to be like, okay, wait. So, because it's not as easy as just understanding that you're working biceps or brachials, brachioradials. But I promise you, if you play around with this, the more you play around with it, the easier it gets. And the more you can understand these muscles, I'm telling you guys, in grad school and in practice, it's going to make such a difference when there's certain obliques that you have to innervate more, and you have to know how to do it. And then there's certain you have to not. You have to be able to know how to do it. So we have to specifically know which ones are being targeted in certain quadrants and certain exercises. Okay? All right, guys, you have a good day.